Hi, it's 9:30. We'll wait for 3 or 4 more minutes and check if more people are like joining the session. Else, I will start the session. Is that okay? Is it okay? Can someone respond?
Okay, madam.
Okay, thank you. Okay, I think it will become too late, so like we can join. I mean, like we
We
can.
can.
Okay, so let's start the session for today. Okay, so first let me share my screen. So, to introduce myself, I'm Shiva Shankari. I'm a PMRF scholar from IIT Madras. I'm working, my PhD is basically like removal of emerging contaminants via catalytic process. So, I have like done my MTech in environmental engineering from NIT Tiruchirappalli. So, today I'm handling the live interaction session for the um, wastewater treatment and recycling and PITL course, for this time along with two other TAs. So now let's like begin with the class. First, first of all, in this entire week, what all the professor has like started to engage was natural purification systems, before that it's transport and fate of the contaminants, then also about the reaction kinetics. Okay, so um, I'll be like discussing problems on. So this is the theory he has discussed, and coming to the problems today, we'll be discussing on problems related to BOD, dilutions, and reactor, reactors, and mass balance. Okay, so these are the problems we'll be discussing on. So I have some 10 problems. Let me my screen here. One second. Is my screen visible to everyone? Everyone is
Yes,
present?
madam.
Okay. So, this is the live session 4. So, like first is a problem. It's not related to like maybe mass balance, but similar to mass balance. This will like help you understand the practicality. So, can you all like write down this problem, like the given details? The first thing is like there is a large tank, and the area of the tank is 1000 meters, and a side wall depth of 10 meter is used as an equalizer. One second. I must to try. Okay. Again, I'm coming. A large reactor, a large tank with floor area of 1000 meters and a side wall depth of 10 meter is used as an equalization reservoir. Flow out of the basin is 0.3 meter cube per second, while the flow inside the um, basin is given by this equation. Plot the Orley values of water depth versus time, assuming H naught is equal to 5 meters and time is equal to um, T naught. That is initial time when time is equal to 0. Okay, so please note down. I will share the screen from here and then we can solve it together. Have you all noted down the problem? So the given is my screen visible? Is my iPad visible? Can someone like tell me if my iPad is like visible, whatever I'm writing? Is it visible? Can someone tell me is it visible? Okay, yeah, it's visible from the screen. So it should be visible. Okay. So given the area of the tank 2000 meter square, side wall depth flow equal to 0.3 meter cube per second, and this is flow out. Flow in is given by this equation 0.3 into 1 plus cos of pi t divided by this is flow in. So thing is this is the reactor equalization tank you can keep. Okay, so the flow in is variable flow of 0.3 into 1 plus cos of pi t divided by 43200. Okay, and the flow out is 0.3. Okay, so flow in is known, flow out is known. Okay, so tell me one thing. The flow in is varying, but the flow out is constant. So will the depth of the water in the tank vary? Can someone answer? Okay, yeah, it will vary. The depth will vary because the inflow is varying. So since the inflow is varying, the depth of the water will be varying. And this entire side wall depth is 10 meters. This floor area is given as so the depth of the water in the tank will vary as the inflow is variable. Okay, so we have to find this change in depth with respect to time from 0 to 24 hours. Okay, so this is what you have to find. So now if we write the mass balance for water flow, it's going to be the change in depth dH by dt is equal to inlet Q in minus Q out, right? Is this understood? The depth, okay, depth into area, yeah. Area into height will give volume. See here, change in volume is equal to uh, rate of volume we can keep. Okay, this is rate of change of volume. Rate in minus rate out, right? But then in the rate of change of volume, the area remains the same. Only the height of the water depth is going to vary with respect to time. That's why I have written area with respect to like time. Okay, so this is the thing. That implies, so now let's substitute A into dH by dt will be equal to 0.3 into, where is it? Okay, I'll check my screen. 0.3 into 1 plus cos of pi t divided by four equal double zero minus 0.3. Okay, so 1000 into dH by dt equal to 0.3 plus cos of pi t divided by 43200 into 0.3 minus 0.3. So this will get cancelled. So dH by dt is equal to cos of pi t divided by 43200 into 0.3 into 10 to the power minus 3. This 1000 I'm bringing over here. So now we have to integrate. To integrate dH by dt, it will become h minus h naught is equal to sine of pi t divided by 43200 the whole divided by pi divided by 43200 into 0.3 into 10 to the power minus 3. So the final equation will be h is equal to h naught plus sine of pi t divided by 43200 into 43200 into 3 into 10 to the power minus 4 divided by pi. So now you know the depth variation with respect to time. So now we have to plot it. Okay, so for plotting I have used Excel. Let me share my other screen. So this is the equation I have derived, and then So this is the after integration, this is what you have got, and then the same I have got as well. So now I have plotted it in the Excel. So time from 0 to 24 hours I have written, and in the equation this t is in seconds, so I have converted it to seconds, and I have just made it as a table. Then the depth, for that I have inserted the Excel formula with the expression I have got from the integral of the equation. So it is basically 5 plus 43200 into 3 into 10 to the power minus 4 into 7 divided by 22 into sine of pi t divided by 43200, which is nothing but 22 by 7 into the time into 43 divided by 43200. So when I insert that, when I just insert that, and then I have dragged and good, and this is the depth variation with respect to time. So the depth, if we see the side wall, the mm, if we see here, the side wall depth is 10 meters, and the depth is varying less than 10 meters. So that's always the problem. Mm, do anyone have any doubts in this problem solving, in this problem, particularly in this problem, or I will move to the next problem? Hemant, do you have any problem in solving this problem? Okay, so I think you don't have any problem, so let me move to the next question. Okay, so a lagoon, next question is a lagoon with 1500 meter cube receives an industrial wastewater flow of 1000 meter cube containing a conservative pollutant at a concentration of 20 mg per liter. Assuming the complete mix conditions are achieved in the lagoon, determine the concentration of the conservative pollutant in the effluent from the lagoon at a steady state. Okay, so let me start writing this. Please note down this problem, question of the problem. Okay, so in this problem, what is given is volume of the lagoon equal to 1500 meter cube receives an industrial wastewater conservative pollutant of concentration equal to 20 mg per liter is present. Complete mix conditions. Okay, so this is the lagoon. Inlet is the concentration of the 20 mg per liter. So assuming this is a complete mixing happens, which means the concentration out will be equal to the concentration in the lagoon. Okay, determine the conservation of the effluent at a steady state. Okay, so steady state is given. So which means dc by dt. Okay, so which means dc by dt equal to 0, and this is a conservative pollutant as well. Let me write the mass balance. V into dc by dt is equal to q c in minus q c out plus or minus reaction rate. This is the mass balance. However, this plus or minus reaction rate is equal to 0 since conservative. Pollutant, and this dc by dt equal to 0 since it is steady state. So overall q in is equal to q out. Okay, so q in c in is equal to q out c out. One second, someone wants to join the meeting. Okay, so q in c in is equal to q out c out. Okay, so now you know q in is equal to 100 meter cube into 20 is equal to q out also will be 100 into c out, that is x. Okay, so now tell me what will be the concentration out c out of the lagoon. Can someone tell me? Simple calculation. Okay, so the C out will be 20 mg per liter. Okay, so that's all with this problem. Let me share the next problem. Okay, so if you see the same thing like I have like given in a like printed format. So if you see uh, here Q in C in is equal to Q out C out because the steady state is present and the pollutant is conservative pollutant. So which implies C out will be equal to 20 mg per liter. So that's all with this problem. So now um, moving to the next problem. The next problem is a dilution problem. So a sewage pipe from a wastewater treatment plant has 1 meter cube per second of effluent containing 5 mg per liter of phosphorus compounds, okay, into the river with an upstream flow rate of 25 meter cube per second, and the phosphorus concentration is 0.01 mg phosphorus per liter, which is resulting in a constant. So what will be the resulting concentration of the phosphorus in the river downstream of the sewage outlet? Okay, so this is the question. Okay, so have you all noted down the question? I will like share my iPad and then like discuss the answer. So problem number 3. Given this is the scenario. I'm gonna draw the scenario. So this is the river and the flow Q of the river is equal to this is the discharge. Let us take this as Q2 equal to 1 meter cube per second with phosphorus P2 equal to 5 mg per liter. Okay, and here at this point already Q1 is equal to Q1 is equal to it is given in the question as 25 meter cube per second. Okay, with P1 P2 P1 is equal to 0.01 mg per liter. Okay, so after this point complete mixing takes place at this point. So complete mixing takes place at this point. So after complete mixing, this from this point onwards, the flow will be Q1 plus Q2. Okay. So as per the dilution formula, uh, the this phosphorus Q1 plus Q2 is equal to Q3. We can keep phosphorus at this point after the dilution Q3 P3 will be equal to, as per the dilution formula, P3 is equal to P1 Q1 plus P2 Q2 divided by Q3, which is nothing but Q1 plus Q2. Okay. Okay, so now when we substitute everything, we get P3 equal to 0.01 into Q1 is nothing but 25 plus P2 is nothing but 5 into 1 divided by 25 plus 1. Okay, can someone like solve and tell me what is the what will be the value? It's a simple calculation. 0.01 into 25 will be equal to 0.25. So this is nothing but 0.25 plus 5 divided by 26, which is equal to 5.25 divided by 26. Can someone tell me the answer? Chandra, can you tell me the answer? 5.25 divided by 26. Ravikant, can you tell me the answer? 5.25 divided by 26. Okay, excellent. The answer is 0.20. Okay, yeah, 0.20. Okay, so that will be the phosphorus um in the, okay, I'm sorry, 0. So that will be the phosphorus present in the stream after the dilution has taken place. Is it clear for everyone? Is it clear, or like should I explain it again? Or shall I move to the next problem? Let me move to the next problem then. Okay, so this is the like previous problem only. I'll just revise it like in a minute. So if we see here, this is the river and Q1 is equal to Q1 is equal to 25, 0.01, and I have like applied the dilution formula and have got the answer as 0.2. So that's it with this problem. So now let's move to the next problem. Okay, so the next problem is, please note down, we have been given time versus concentration, and then it follows the first order reaction rate. Okay, so now we have to find what is the concentration at 20 minutes. Okay, so that's our task. So yeah, let me like share my screen from my iPad. So time is given as 0, 2, 4, 6, 8. Okay, and then concentration, time in minute, concentration in mg per liter. Okay, so it is given as 40, 60, 110, 200, and then 325. Okay, so now it is given that it follows first order reaction rate. So first we can find C by C naught. This will be your C naught, and then C will be weighing. C weighs. And then we have to find ln of C by C naught. Okay. So what we are going to do is we are just going to like uh, find what is the reaction rate constant and then solve the linear equation to get what will be the concentration at 20 minutes of time. Okay. So C by C naught, if we see for first one it's going to be 1 because 40 divided by 40. Can someone tell me C by C naught of 60 by 40? 60 by 40 will be equal to, it's nothing but 3 by 2, which is 1.5, which is 1.5. And then, 1 second. Okay, so next is 110 by 40. 110 by 40, which will be equal to 2.75. Okay, then 200 by 40 equal to 5, and then 325 by 40 will be equal to 8.125. Okay, so now we have to take the ln of all the values. So ln of 1 will be equal to 0. Ln of C by C naught is equal to ln of 1 is equal to 1. Then ln of 1.5 is equal to 0.405. Then ln of 2.75 is equal to approximately 1. And then ln of 5 will be equal to 1.6. Then ln of 8.125 will be approximately equal to 2.09. Okay, so now we have to make a plot between time versus time in minutes versus ln of C by C naught in the y-axis. Okay, so we have to plot between these two. So you will get a straight line, and from the straight line you will get the equation. Get the equation of the straight line and try to solve what will be the concentration at 20 minutes. Okay, so let me share my screen. I have solved it in Excel easily. So time in minutes I have taken in the x-axis, and then concentration we know C by C naught I have calculated, and then ln of C by C naught also I have calculated. So now I have made a plot between time and this ln of C by C naught, and this is the graph I have obtained. So from the graph we can take the equation of the we can take what will be the equation of the line. So the equation of the line is nothing but 0. Y is equal to 0.2697 x minus 0.0545. Okay, so this is the equation obtained. Okay, so now In the x, it is nothing but time, right? Time in minutes. And in the question, we have been asked at 20 minutes. So just substitute 20 in this equation. If you substitute, you will get y is equal to 0.2697 into 20 minus 0.0545. Okay, then again if you solve, you will get y, which is nothing but c by c naught. This is nothing but ln of c by c naught equal to y is equal to 0.2697 into 20 minus 0.0545. Okay, so you will get something like this. So when you try to solve this, what you will get is ln of c by c naught will be equal to ln of c by c naught will be equal to, can someone tell me the answer? Ravikant, can you tell me the answer? What will be the value of ln of c by c naught? 0.2697 into 20 minus 0.0545. Can you solve and tell me? It's simple. Ravikant. Okay, let me solve it now. So if you see, the value will be equal to excellent, yeah, that is the answer. I mean, ln of c by c naught is equal to 5.3395. So from this, you have to get e to the power of, if we have to get the exponential value of this, okay, so that we will get the c by c naught. So c by c naught will be equal to exponential of 5.3395. What will be the answer for this exponential of 5.3395? Can you tell me, Ravikant? Ravikant? Okay. So in that case, it will be equal to 208. So c by c naught is yeah, very good, very good. Yeah, it is 208 to 209. So 209.4 is correct answer. So from this you can find c is equal to 209.4 into, what will be the c naught value here? C naught value is 40 into 40. So what is the concentration at 20 minutes then? Can you tell me? 209.4 into 40. Can you tell me, Ravikant? Yeah, excellent. So the answer is 8376. Okay, so this will be your concentration at 20 minutes. Did you understand the problem properly, Ravikant, or should I explain it again? Ravikant, can you understand the problem, or should I? Okay, excellent. So now let's move to the next problem. Okay, let me share my presentation. Okay, so this problem we have solved. Yeah, the concentration we have also got the same similar thing, 8,300 something. And then, okay, in this question, okay, so the next question is basically chemical degrades, which means it is a non-conservative pollutant because it undergoes degradation reaction in a flow balanced steady state completely mixed flow reactor, which is nothing but CSTR, completely mixed the tank reactor. It is the same one according to first order kinetics. Okay. The upstream concentration of the chemical is 10 mg per liter and the downstream concentration of the pollutant is 2 mg per liter. Water is being treated at a rate of 25 meter cube per minute. The volume of the tank is 590 meter. What is the rate of the decay? Okay, so let's solve this problem. Okay, this is problem 5 given. This is the reactor inflow, outflow, and here it's going to be inflow is nothing but 10 mg per liter. Outflow it is 2 mg per liter. Okay, Q in is equal to 29 meter cube per minute. Q out is also equal to 29 meter cube per minute. Okay, so inside it undergoes decay reaction, non-conservative pollutant. So now dV by dt into concentration is equal to Q in C in minus Q out C out minus dq rate. Okay, dV by dt. Okay, so but this rate of accumulation, this will be equal to 0 in case of steady state reaction. Okay, so now we have these three parameters, okay, which is nothing but into concentration. Okay, so now we have Q in C in is equal to Q out C out plus K into C out into volume of the reactor. Okay, so now just substitute all these values. Okay, so it's nothing but 29 meter cube per minute into concentration is nothing but inlet concentration is 10 equal to 29 into 2 plus K we don't know, that is what we have to find, into 2 into volume of the reactor is nothing but it is given in the question as 590 meter cube. Okay, so if you just try to solve, it will be 29 into 10 minus 2 is equal to K into 2 into 590. Okay, so which is nothing but 29 into 8 is equal to K into 2 into 590. It's going to be 4, it's going to be 1, it's going to be 29 into 4 divided by 590, which will be K in minute power minus 1. Can you tell me what will be the value of K in this case? 29 into 4 divided by 590. Ravikant, can you tell me the answer? 29 into 4 divided by 590. Yeah, excellent. So K is equal to 0.197 minute power minus 1. So that's the answer. Have you understood how to solve this problem completely? Or should I explain it again, Ravikant? Okay, great. So now let's move to the next problem. Okay, so in this problem, this is the printed format of the problem. And then the K value is equal to 0.197 we have got. It's okay, 196, it's correct. So yeah. So next question is also related to the reactor kinetics. So we are given alum dosage is 50 mg per liter. K is equal to 90 per day. Based on the laboratory test, compute the retention time for complete mixing for reduction of 90% concentration. Okay. So let me just share my iPad. Given alum dosage equal to 50 mg per liter. K is equal to 90 per day. Okay, and then retention time is what is asked. Okay, for 90% reduction in concentration. For a completely mixed reactor, that is CMF4, the previous one we discussed. Okay, so we have to find what is the concentration for 90% reduction of the initial concentration. So first let's find what will be the 90% reduced concentration, that is CE. It is going to be reduced to 90%, right? So initial concentration equal to 50. So 90% reduced concentration is nothing but 50 into 1 minus 0.9. I think you might have understood, because if 90% is like getting reduced, then the remaining will be 5%, right? So 5 mg per liter. Okay. So now you know C in and C out is going to be. So now it will be like so 90% reduction is nothing but 5 mg per liter. Okay, and now it's going to be like the formula for like completely mixed stir tank reactor under a batch process is nothing but ln of C by C naught is equal to KT, which is nothing but the formula is T is equal to 1 by K into C in minus C out divided by C out, which is equal to, so now we have to find, we know K. Okay, so 1 by 90 into C minus C out divided by C out. So which is nothing but 50 minus 5 divided by 5 will be equal to our time. Okay, so it's nothing but T is equal to 1 by 90 into 45 by 5. So if you cancel, this is going to be 5 again, and this is going to be 10, which is equal to, time is equal to 1 by 10, which is nothing but 0.2 days. Is it clear? Zero point 0.2 days means, which is equal to 144 minutes if you convert into minutes. Is it clear for everyone? Okay. So now let's move to the next question. Problem number 7. Okay. So now we are going to the BOD related problems. Okay, so as I have told, we have 3 different types of problem to be solved today. So the first one is the reaction kinetics, the BOD based problems, and then we have this reaction rate constant and everything, the dilution problems. So all other problems like mostly it's like discussed. Now I'm going to move to the BOD problem. So in this problem, what is like given as 7-day BOD at 92 degrees centigrade is equal to 80 mg per liter. So now we have to calculate, find out ultimate BOD thing is the 5-day BOD at 20 degrees centigrade. And given the reaction rate constant is equal to okay, I'm not sharing the iPad. I'm very sorry about that. See it. The base is equal to 0.23 d power minus 1. Okay, at 20 degree centigrade. So now theta t is equal to 1.047. First, let's convert the theta, the temperature, and then let's proceed. Okay, so given kT is equal to so now we should know this relationship. KT is equal to K20 into theta to the power t minus 20. Okay, so this is the relationship. So when we put K22 degree centigrade is equal to 0.23 into 1.047 the whole power 22 minus 20. Okay, so K22 is nothing but 0.23 into 1.047 the whole power 2. Okay, if you substitute, you will get the answer as 0.25 per day. Okay, so now you know what is this thing. Okay, so now let's move to we have to determine the ultimate BOD. Okay, so L naught into 1 minus e to the power minus kT is equal to 80 mg per liter. T is equal to 7 days, and then we have L naught is equal to 80 divided by 1 minus e to the power minus 0.25 into 7. Okay, so can you solve and tell me the answer, Ravikant? 80 divided by 1 minus e to the power is going to be minus 1.75 is equal to, Ravikant, can you tell me the answer? I will wait for a minute. Is it okay? Ravikant, can you tell me the answer? I will wait for 1 minute. Ninety-six. Okay, super. That is the answer. So 96 mg per liter. Okay. So now next step is we have to find what is the 5-day BOD at 20 degrees centigrade. So now B 5-day BOD at 20 degree centigrade. Okay, so now we know the ultimate BOD. Okay, so 5 days BOD will be BOD 5 is equal to L naught into 1 minus e to the power minus kT. Okay, 1 minus e to the power minus kT. Okay, which is nothing but 96 into 1 minus e to the power minus at 20 degrees centigrade. So we have to use this 0.23, okay, not 0.24, minus 0.23 into 5 is equal to 96 into 1 minus e to the power minus 5 1.15. Can you tell me the answer? Avikant, 96 into 1 minus e to the power minus 1.15. What will be the answer, Avikant? I will wait for 1 minute. Ravikant, can you tell me the answer? Okay. Excellent. The answer is 65 mg per liter. Very good. So now let's move to the next problem. Okay. Did you understand the problem properly, or like should I explain it again? Ravikant? Ah, great. Now let's move to the next problem. Okay. Moving to the next problem. An organic waste sample has molecular formula as C5H7O2N. Its concentration in the waste stream is 250 mg per liter. Calculate the BOD, MBOD, ultimate carbonaceous BOD, and ultimate oxygen demand in mg per liter, and BOD5 divided by given BOD5 divided by BOD ultimate is equal to 0.68. Okay, so BOD, what we tell is like simple BOD here. What is mentioned is nothing but the carbonaceous BOD. Okay, so which is nothing but the amount of oxygen required to convert the carbon to carbon dioxide by the organic molecule, by the microorganisms. Okay, so if we see theoretically, in the last class we would have imagined, I mean, like I would have thought how to convert this, how to find the BOD, that is nothing but the carbonaceous BOD, when the molecular formula of a pollutant or like molecule is given. Okay, so it's nothing but this one. Okay, let me just share screen. So the molecular formula is C5H7O2N. So now this is going to be converted to CO2 molecule in the presence of oxygen. Okay, we have 5 carbon. So here it is going to be 5. H2O, we have 7 H2O. So here it's going to be this one will be like 1 and 3, and remaining will be 4. So 4 divided by 2 is nothing but 2. Okay, so this will be this. So if we try to like do the mass balance for oxygen, it's going to be here it is 10 and here it is 2. So in this side it is 12, but this side it is only 2. So here it should be 5, because 12 minus 2 is equal to 10 divided by 2 equal to 5. So the overall balanced equation is this one. Okay, nothing but, I will write clearly, C5H7 O2N plus 5O2 gives 5CO2 plus NH3 plus 2H2O. Okay, so now we have to find what is this um, molecular terms of this. We have been given the concentration of this is nothing but 250 mg per liter. So now we have to find the molecular weight. Just nothing but 12 into 5 plus 7 plus 16 into 2 plus 14. Just nothing but 7 plus 32 plus 15 into 6 46 plus okay, excellent. The answer is 113. Okay, so here it is 113. So now we have 250 divided by 113 is equal to x divided by 5 into 16 into 2. Okay, now try to find the x value. It will give the concentration of O2 required, so that will be your BOD. Okay, that is carbonaceous BOD, carbonaceous amount of oxygen required to convert the carbon in the compound to CO2. Okay, so x is nothing but 5 into 16 into 2 into 250 divided by 113. Can you tell me the answer, Ravikant? I will wait for 1 minute. Can you tell me the answer? Okay, so it is 354 mg per liter. Okay. Let me check anyway. Yeah, it is 355, 354. So that is okay. So this is nothing but our ultimate carbonaceous BOD. Okay. So now we have to convert it into BOD5. Okay. So now we are given BOD5 divided by BOD ultimate is equal to 0.68. Okay. Means BOD5, from this you can find what is BOD5. Zero point 683 BOD ultimate. Yeah, excellent. So BOD5 is nothing but 240.72 mg per liter. Okay. So now you have found BOD, carbonaceous BOD, ultimate BOD, I mean ultimate carbonaceous BOD and BOD5. Now we have to find what is the NBOD. Okay, so for finding the NBOD we have this ammonia, right? So for we have only one ammonia will be released from the compound. Okay, so for oxidizing one ammonia, how much O2 molecule will be required? Okay, that we have to check. So NH2, let me write the equation for you so that it will be easy for you to solve. NH3 plus 2O2 gives HNO3 plus H2. Okay, so this is the equation. So now for that, first you have to find what will be the concentration of ammonia released from this. Okay, so let's go to that. Okay, so 250 mg per liter of this compound with molecular weight 113 can produce. What is the molecular weight of ammonia? It is nothing but 14 plus 3, 17. Okay, so here it is X. So X is equal to ammonia's concentration, which is nothing but 250 divided by 113 into 17. Can you tell me what is the answer for concentration of ammonia? Yeah, 37.62. Okay, now you know this is 37.62. From this we have to find what is this 2O2. Okay, so 37.62 divided by 17 is equal to 16 into 2 into 2. This will be your NDOD. Okay, which is equal to, this is the 2O2, like required 2O2. So that will be nothing but your NDOD. So implies NDOD is equal to 16 into 2 into 2 into 37.62 divided by 17. Can you tell me what is the answer? Ravikant and Chandra. 141.63. Okay, so this will be your NBOD. Okay, so now total oxygen demand, like considering ultimate CBOD and NBOD. So total oxygen demand equal to ultimate CBOD plus NBOD, which is nothing but ultimate CBOD is nothing but 354 plus 141.63. Can you tell me the answer, Ravikant? Ravikant? 495.63. Yeah, that is the answer. Okay. So now let's move to the next question. Okay. In this question, a student has begun an experiment of 5-day period at 20 degrees centigrade on Monday. Since the fifth day fell on Saturday, the final DO reading was taken on Monday. On calculation, DOD 7-day at 20 degrees centigrade was found to be 150 mg per liter. Assume the BOD rate constant at standard temperature of 20 degrees centigrade as 0.23 to the base E, what would be the 5-day BOD at 20 degrees centigrade? Okay, so now we are given problem number 8. Seven-day BOD equal to 150 mg per liter at 20 degrees centigrade. Okay. Now, what is the 5-day BOD 20 degrees centigrade with Q equal to 0.23 per day? Okay. So, BOD 7 is equal to BOD ultimate into 1 minus e to the power minus k into 7. Okay. So, and then we are given but we have to find what is BOD 5. 5 is nothing but BOD ultimate into 1 minus e to the power minus k into 5. Okay. So if you write BOD 5 divided by BOD 7, one 187.47. 1 second. I don't think we need to find the BOD ultimate. 5-day BOD only we have to find. Okay. Equal to 1 minus e to the power minus k into 5. Here k is equal to 0.23 into 5 divided by 1 minus e to the power 0.23 into 7 implies BOD 5 divided by BOD 5 is equal to BOD 7 into 1 minus e to the power minus 0.23 into 5 divided by 1 minus e to the power minus 0.23 into 7. To find then BOD 5 will be what? BOD 7 here it is given us 150. Can you find the answer? Internet will put something. Oh, 128.11. Excellent. Yeah. Okay. I think that is the right answer. Let me check the answer. Yeah, that's the right answer. Very good. Very good. Okay. So the answer is 128.1 mg per liter. Okay. So now let's move to the next question. Okay. So the next question is just give me a minute. Okay. In this question, we have been given two wastewater discharge stream discharges into a river. The ultimate BOD L0 and 5-day BOD BOD5 of the combined flow after mixing we have to find. Okay. So given is that QA stream A has 2 mld with L naught A is equal to 200 mg per liter, and then stream B QB has 3 mld L naught B, that is the BOD in stream B is equal to 100 mg per liter. Okay, so the river itself has a flow of 10 mld and the background ultimate BOD in the river is nothing but 2 mg per liter. So assume 20 degree centigrade and the deoxygenation rate constant as 0.23. So now we have to find what will be the BOD after complete mixing. Okay. So what is given is stream A which QA is equal to 4 mld and then BOD L naught A is equal to 200 mg per liter. Okay, and stream B will be equal to 3 mld L naught B is equal to 100 mg per liter. Okay, and then river flow equal to 10 mld and BOD of the river is equal to 2 mg per liter. Deoxygenation rate constant K is equal to 0.4 per day. Okay, we have a river. We have two streams flowing towards the river. River has QR. Here it is QR. Where it is QR plus QA plus QB. This is stream A, so this is QA, and this is going to be QB. Before this section, only QR is present, but after mixing with two streams, QA and QB, the total flow becomes QR into QA plus QB. Okay, and now we are given here LOA is equal to 200 mg per liter. Okay, and LOB is equal to 100 mg per liter, and then BOD of the river is nothing but 2 mg per liter. So now we can use the dilution formula. Okay, as told earlier. So it's nothing but for three things we have to put the dilution formula. So it's nothing but we have to find what is the this after mixing. Okay, so it's nothing but BOD after mixing is equal to QA into LOA plus QB into LOB plus Q river into LO river, the whole divided by QA plus QB plus QR. Okay, just nothing but 2 ml into 200 mg per liter plus 3 ml into 100 mg per liter plus Q river is nothing but here given river flow is 10 ml into 2 mg per liter divided by 2 plus 3 plus 10, which is nothing but 400 plus 300 plus 20 divided by 50, which is equal to 4 320 divided by, I'm sorry, it's 700, I'm sorry, 720 divided by 15, which is nothing but 3 table if we put 2, 1, 4, 3, 240, and then 5 table if we put, it's going to be 4, 48. So PUD after mixing with nothing but 48 mg per liter. Okay, did you understand? Yeah, that's what we have got. And then we have, this is the ultimate BOD. Okay, so from this we have to find ultimate BOD after mixing. So 48 mg per liter. From this we have to find BOD 5. BOD 5 is nothing but BOD ultimate into 1 minus e to the power minus 2 is nothing but 48 into 1 minus e to the power minus 0.3. Can you tell me what is the answer? Yeah, that's correct. 32.8 mg per liter. Okay, so that is the correct answer. Now let's move to the last problem. Did you understand the problem completely, Ravikant? Okay, good. Chandra, did you understand the problem? Or should I explain it again? Is that required? Okay, got it. Now let's move to next problem. That is the last problem for the session. Is my screen visible? The question is visible? Yeah, okay. Okay. So using the set of data, we have given time versus concentration. And it follows first order reaction. Okay. And we have to find the coefficient of the rate constant K and how long it will take for the pollution to reach a concentration equal to 30 mg per liter. What will be the pollution concentration in 5 days? Okay, all these things you will be able to do it in Excel. Okay, so time is nothing but 0, 12, 24, 48, 96, 144. Concentration is nothing but 270, 240, 220, 180, 125 and 95. Okay, and first thing, okay, I'm sorry I didn't share the question. Maybe is the question visible, Ravikant? I will wait for 2 minutes so that like you can copy the question. Did you copy the question, Ravikant? Can I start the problem or we need more time? Okay, excellent. Now let's solve this question in Excel so that like it will be very easy for you instead of like doing everything manually in iPad. So in Excel, if we open, let's go to this one. Okay, first type time concentration. Time is given in hours. Okay, concentration in mg per liter. Then C by C naught. And then it will be 1 of C by okay. Now you have to type the time. Okay, it's nothing but 0, 12, 24, 48, 96, 144. Yeah, it's first order. And then that's correct. Let's plot it. So this is the plot we have obtained. And then let's add a trend line, get its equation. So this is the equation. K is equal to 0.0085. It comes around 0.0075, but that should be okay. I'm not sure. Okay, for that 258 hours. Let me check. 98 mg per liter. Okay. Let me check the answer. It's first order, that's right. Yeah, this one is wrong, Chandra. I'm not sure. Like, it should be 0.0074. That's what I'm also getting, 74 or 75. That's the answer we are getting. And then, so if there is some issue with that, then one second, let me check what is the answer you have told. No, actually, since the slope you have like told is like wrong, the slope value is nothing but 0.0076 or 0.0074. So, because of that, the answer is varying, Chandra. I think you have to check the calculation. Is that okay? Or you can just see my Excel. See here. First, I have like given the time, concentration, and then C by C naught values I have calculated. Then I have taken ln of C by C naught, okay, and then dragged it down, and then I have got this plot where the x-axis is nothing but time, and here it's going to be ln of C by C naught. Okay, so if you get this, then from this, what you can do is you can just get the slope of the equation directly, which is nothing but 0.0075 or 0.0076. So when you know it is 0.0076, so y is equal to 0.0076. So rate constant is equal to 0.0076. Okay, so from this what we were supposed to find is how long did the pollution take to get a concentration of 30 mg per liter? Okay, so the concentration is 30 mg per liter, which means C. Okay, implies C by C naught is equal to 30 divided by 270, which is equal to 1 by 9. Okay, then ln of 1 by much will we get? Just making that minus 2.197. Okay, so this will be your y value. From this you have to find time t, which is implied, which implies 36.76 is equal to 8.9 divided by 0.76. Which is nothing but so the answer is 289. I think that's what you told as well, Chandra. Let me check. Okay, yeah, you told 258 hours. Okay, so the answer is 289. Okay, and then since we know the equation, this is the equation y is equal to, this is the equation. So now we have to find at what time after 5 days, right? The question. What will be the pollution concentration in 5 days? Okay. So 5 days is nothing but in hours if you convert 5 into 24, which is nothing but 96 hours. Okay, so if it is 96 hours, you have to just like put that over here, which is nothing but ln of C by C naught is equal to 0.0076 into 96, which is equal to 120. Let me check on first. It comes 110 approximately. Oh, this one you are telling 96. Okay, okay, got it. This one is nothing but how much did you tell? 120, right? 120. So if you calculate, it's going to be ln of C by C naught is equal to 2.48. 72.3. Let me check. No, it's not the right answer. Wait. Ln of c by c naught is equal to exponential. No, no, this is exponential. Oh, I'm sorry. This is c by c naught is equal to 2.48 implies c is equal to 2.48 into c naught. It's nothing but 270. I think we have made some mistake. There is some issue. I'm not sure what is the issue. Let's check the solution. Okay. In 5 days, 120 e plus 5 y is equal to 4.89 in concentration. Okay. Yeah. So 109.86 is the right answer. So yeah, I will share the solution as well in the folder, like live session folder. You can just download and check the solution. Now it's like time to wind up the class. So do anyone have any questions in this week? Do you guys have any questions, any doubts or clarifications? If not, I will wind up the session. Is that okay? Chandra and Radhika? Okay. Thank you so much for attending the session. All the best for your exam. Keep studying. You can thank you. You can attend all week like live sessions, and this will be also like streamed in YouTube. So whenever like you have time, you can like see that as well. So that's all from my end. Thank you so much for attending the session. Like see you in my next class. Thank you. Bye bye. Is it okay if I leave, or do you have any doubts? No doubt, right? Okay, so let me leave the session. Thank you.